Okay, so it just hit 4:30, so we're going to go ahead and get started because I have, as it turns out, quite a few slides. So this is actually this is about the crowd I was expecting, actually. You all right, dude? All right. So I'm just going to ask a couple real quick questions just to get a gauge of experience, knowledge, and things like that. So how many people bought something on Xbox Live Indie Games, just to show of hands? Oh, wow, a lot of you. Okay, cool. How many developed for XBLIG? Yeah. Good enough. So we have at least one developer. How many of you just have experience making games at all? Like any engine, doesn't have to be at any level. Yeah, I mean, it doesn't have to be like intensive experience. But if you're familiar with development, well, I'll add some context. I'll just get started. So to just do the preliminary stuff real quick. So basically how this is going to work is, it turns out this is actually going to go on YouTube apparently, and then I'm going to start recording now. So this time I'm actually recording. I didn't do that last year because I'm not very smart. And all the files for anything that I come up with throughout this presentation will be at tinyurl.com/xnamag. You can find me on social media, Twitter and Google Plus for like the 5 people that use that. And it turns out I was just told that one of the reasons you should have Guidebook, which if you're a MAG regular, you probably have Guidebook already. Apparently there's now a feedback thing in Guidebook for panels. So if you download Guidebook, please give feedback on this because I normally don't get like formally written feedback for things. So the fact that they have that for us at MAG is kind of awesome. So please do that because I'm sure people at the MAG staff probably spent an inordinate amount of time on things that they're probably really scared that nobody will use. So please use it. So a really quick rundown of who I am. So I've been working in the games industry as a professional for about 5-6 years or so. I've shipped over 50 games, worked on even more than that. Worked on lots and lots of packages because most of my expertise is in multi-platform, so usually a single game I'm usually maintaining at least like 4 different packages for it, if not more than that. Pretty much everything that I write, that I own the rights to, goes on GitHub because I'm very much an open source developer. I'm a Linux gamer and a Linux developer, so that's just sort of just in my blood in general. If you're familiar with libraries like SDL or OpenAL, Mojo Shader, or like things like that, like I do a lot of game development libraries, work on game development libraries because I try to share as much as I can because game development's hard as it is. And like a lot of what I talk about is specifically porting, but just to kind of give a broad example of the kind of things I do, be it ports and other types of things. If you squint hard enough, you might recognize some of these games. This is sort of a broad version of my catalog. Actually, no, it's pretty good resolution. So you might be able to see that without squinting. So I was a little bit worried about that. So for context of why this presentation exists, there used to be a site until last December called Patreon that I used for sort of minor fundraising to do some open source development of XNA preservation. And one of the things I did was posted a little bit about sort of, pretty much it was, if you like Google the name of this presentation, you will find like this Patreon post. It was very developer-centric though, because I was trying to make an appeal to developers who may have shipped something on XBLIG, but never actually brought it out of XBLIG, because as of September, or no, it was like the first week of October, I think, is when they officially started pulling stuff from the store. I don't know how effective that ended up being, but I'm still working very hard to see if I can't get some of the lost gems of the library and bring them to the PC or wherever platform developers wish they could develop for now. This isn't going to be terribly developer-centric. I'm trying to make it have more broad appeal. There is one section where that gets a little bit technical, but you don't have to be like a super experienced game developer to understand what's going on in this presentation. So this is the part where I have to point out that I'm independent and not speaking on behalf of anyone who worked on XNA because, as you can see on this slide, I have mixed feelings about XNA. Having implemented most of XNA from scratch myself, I can say these things because it becomes abundantly clear that one of the reasons XNA died is because it was kind of a vehicle for all these different projects Microsoft was doing for game development at the time. And one by one, throughout XNA's lifetime, pretty much all of them failed. So pretty much by the time all of them failed, XNA was kind of the last thing left on the chopping block, and sure enough, it was discontinued. Most people, when they talk about, because it's called the XNA framework, but in reality, it's mostly just like, it basically is just a C# wrapper around like a Direct 3D graphics device, or like a wrapper around like a sound buffer and a sound instance. There is a game class, and it's stored in something, it's like Microsoft XNA.framework.game.dll, and that actually hosts all the frameworky stuff, and the framework is basically just one class that gives you two functions, update and draw, with a timer. And that's kind of all you're given. It's much more direct than what you might expect if you're familiar with like frameworks or like entire engines like Unity, where like you're basically given very, very little control over how the program is structured. But the only reason, well, the main reason, despite all of that I just said, the reason that people used XNA was because Xbox 360 was a target. That's pretty much the only reason that I can come up with. What's interesting is that when you look back at sort of when XNA was first getting announced, like they were starting to put out previews, they advertised it more as like a learning tool, like learn to make your own games. And so, okay, because like there was a lot of like C# was them trying to get into like the academic route, like where most of like college classes were, you're like starting to move over to like Java and stuff like that. So this was an angle that they kind of took to make C# more appealing, was, oh, you can do like game development courses and have it not be like a horrible C++ nightmare, which is what academics is really terrified of. In my experience when speaking to colleges. What's fascinating is that it's like, it was supposed to be making games development easier, especially for students, but from what I can gather, and having worked on lots of XNA games that ran on the Xbox 360, it was really, really hard to actually target the 360 and have it run well, because when you think about like the .NET framework, like it's like the desktop like .NET Redist, like if you run anything on Steam, you probably have to install .NET and VC Redist and all those things like 1,000 times. The Xbox ran on a version of .NET that, from what I can gather, came from like the Windows CE and Pocket PC. Like this was like embedded devices that I think it was from like 2003 or something like that, and they sort of cobbled something together to make it work on Xbox 360, and the limitations were kind of ridiculous. So like one thing I see a lot, because the heap that you're given is so freaking tiny, there's two things I see in every Xbox game that I've ever shipped that went through cert. One is that there are try catches everywhere, and the catches don't do anything. It's just catch because I don't know why it crashed, so we just add a try to catch block and we get it through cert. And then the other thing that happens is that gc.collect is called like 1 billion times. So what's supposed to be like a managed language where it's like, oh, you don't have to worry about like memory leak and stuff like that. No, you definitely had to care about memory leaks. So you're basically just calling gc.collect like anytime you did anything involving like allocating memory in any way. So loading screens were just like collecting constantly. But despite all these limits, tons and tons of people put out games. There were a couple things that, to be fair, a lot of the limitations were probably to the benefit of players, like the fact that trial mode was basically required. That's something that people complain about now, especially now that Steam Direct is out, and it's like you have no idea what game is good or not. And a trial seems to be coming out on top as pretty much the only way that people are willing to trust you as an independent developer without any sort of prior catalog. It's a shame that like of all the limitations that came out, that was one that we really didn't learn anything from. But that's all on the Xbox 360, and of course we can't really target the Xbox 360 anymore. I guess you could technically target it, but I actually don't know how well it's supported to just to sideload it or whatever. So now really all we have left is XNA on Windows. And what's strange is that they advertised pretty much from the very beginning like, oh, it's cross-platform, you can target Xbox and Windows at the same time. And I'm wondering if there was some sort of disconnect between the people marketing this stuff and the people who were actually developing it, because the PC API is just really bad. It almost feels like they needed it just for a quick iteration, like okay, we just needed some keyboard API. It's not a good keyboard API, but at least lets you enter keys and have things happen on the screen. And it's definitely caused a lot of problems over the years, but you have to remember, this is back when Microsoft was like, in whatever they were taking, where people were just like, oh, nobody games on PCs anymore. It's like everybody's only going to target Xbox. Like nobody's ever going to use XNA just to ship on Windows and only on Xbox 360. And that is exactly why none of the games on this slide exist, which makes me really sad because Axiom Verge is good. I would be very, very pleased if it existed. So, but but the thing is, I mean, joking aside, like having all these XNA games still doing really, really well and being able to still ship with XNA is great. And on the PC, you're not like impervious to like getting bit rotted out of existence. But the problem is that we're now having to deal with the reality that XBLIG actually did disappear. Like we used to joke like, oh, Microsoft will never shut it down. It's like Games for Windows Live. It'll be around for years and years and years. But oh crap, they actually took it down. So we now have to kind of talk about XBLIG. And luckily, it seems like everybody here bought XBLIG games, but when I was writing this, I sort of had to, I had to kind of consider whether or not I was going to bring up the subject of like, I mean, you see all like those YouTube videos from people who are like going through XBLIG games and they're like all really, really crappy and stuff like that. And people had this really bizarre, like especially when Steam Direct came out, people were like, oh, it's going to turn into another XBLIG. Like people act as if XBLIG was like this like fascinating anomaly where like only bad games shipped on XBLIG and nowhere else. So it's like XBLIG was the only market that had like knockoff 2D platformers that flooded the store market. It was the only market that for some reason had, gratuitous boob games where I 100% swear it's 100% about the gameplay and nothing else, I swear. And then there's, I mean, do I even need to comment on this? Can anybody actually identify this game? So you both eventually like got your answers correct like after mixing it up. It's Castle Miner Z, but like I mean, God, how many games are like this now? Yeah. Oh. Yeah, I think it was Digital DNA. He had a ton of stuff on the top. I mean, I make fun of him for this, because I mean, it has a stereotypical look, but I mean, it did well, so, shame on all of us. So I mean, yeah, I do have to kind of, this is something that whenever I talk about XBLIG preservation, I do get the question of like, why would you actually even bother with it? But there is value in it though. Luckily, this seems to be getting less and less of a problem now that there's more perspective of things like itch and Steam Direct showing that XBLIG was not this weird anomaly where just only bad games existed there. But I did want to kind of talk about some of the things that I find valuable about XBLIG. Because everybody, I mean, you get Gama Sutra articles all over the place when like, oh, there's still gems, you just have to find it, and there's always going to be that fight, and you've heard this a million times, so I'm not going to talk about it. What I am going to talk about is the fact that, as it turns out, I mean, on the surface you can't really tell, but as it turns out, the ecosystem that kind of came out of a bunch of amateur programmers working on games for fun or attempt to become a full-time job or even just for academics, turns out some really cool stuff came out of it. And I'm going to be talking about that in a second. And then we're going to actually address like the fact that no matter what value you place it at, we do have to face the fact that we have to figure out what to do with the data now that we can't actually use it in the way that it was originally intended for anymore. And we can't buy it anymore. So you basically have to either pirate it somehow or you have to have managed to download it and figure out how to make it work from there because you can't unlock it if you only have the trial mode, for example. So we're going to stick with these two. We're not going to deal with like the stuff that you can find on any average gaming news site. So this is where I get to talk about the software ecosystem. it's something that usually when I try to talk about it, people think I'm trying to over-intellectualize it, but I really don't have a good way to do this I don't have a good name for this that doesn't take away from the importance of what I'm actually trying to do. So sort of my attempt at visualizing how this is supposed to look is, so we have your game that's written on top of XNA, which is running on top of, in this case, Windows, or it could be Xbox 360, or for the few people who actually targeted Windows Phone, but we're not going to talk about that. But it's pretty simple, I think. You'll see the color coding where I talk about proprietary and FOSS, and we'll get to that later, but just for now, just think about just your game built on top of XNA, built for Windows, for example. And we're going to start from the center and and work our way out. So we're going to start with just the game part. And this is where I get to kind of brag for a little bit, because this is where I can kind of provide some context of my experience with games, which is, this is a game called Pyre. I don't know if you've heard of this small indie studio called Supergiant Games. They've only made 3 really, really good games like Bastion and Transistor. And so it's really great being able to work on stuff like this, because being able to work with teams where they find really, really great ways to integrate technology and art and just like content, for example. Because they actually started, this is actually not an XNA game. Their first game, Bastion, was an XNA game. And then when they moved over to Transistor, they sort of started with like an old version of Monogame that sort of got morphed into this thing that looked neither like Monogame or XNA. And then for Pyre, they just kind of threw out anything that looked like XNA, and just like now they just have it all in one monolithic engine. It's their own thing entirely. It's been really interesting to see their technology evolve over time, especially as they've made their games much, much more demanding of themselves as developers. But there are also guys that I work with where they're still using XNA, and they still manage to make it work within the way that they like to work. So we have games like Owlboy, which, it took a long time to develop, but I think, and it even follows the stereotype of indie games being pixel art, but it looks really good even for a pixel art game, even if you're critical of that type of art style. And people are able to make that work really well. And both this and Pyre are cases where teams are able to work with it. And then there's guys like Dean Dodrill, who was able to, over the course of a few years, with basically his first game programming project, turn basically my first 2D platformer into that, which is, it was one of the great treats throughout my career, was being able to see someone who wasn't necessarily a career engine programmer kind of figure out how to make the code work with his art to make it look and feel how he wanted it to feel. And it's really, really great to see projects like this. But when it comes to the technology side of XNA, the game that I really, really like to talk about is this one. Pretty, isn't it? So it's a game called Murder Miners. I developed Linux and Mac OS versions of this in around 2015. And I wanted to do it actually just because it turns out that it's a pretty good clone of Halo 1. It's sort of it's mostly Halo 1 with little bits and pieces of Halo 2 and 3. And yes, it does have, the voxels mining. I just made fun of it, I know, but they actually use it effectively for if you ever played Halo 2 and 3 Zombies, if you combine that with being able to build and destroy terrain, it actually it's really fun. And it's $2 on Steam, so it's really, really cheap. And it's actually a really, really great example of how the technology is sort of hidden underneath what you actually see. Because typically, when you see anything, we can talk all day about all the demo videos you see for engines, the Unreal Engine 4 demo, the Unity, all the fancy lighting demos and stuff like that. So, but you don't see, you're never going to see an engine demo that looks like that. But it's actually pretty fascinating. So when you start a deathmatch session in Murder Miners, this is the screen you start with. So this is the very first thing you see after you get past the title screen. And so we're going to call this screen step 1. And it's step 1 of basically what my porting process is. So how it works for me is when I'm porting a game to Linux or Mac OS, basically I take the engine source, I try to get it to build, oftentimes it doesn't build, so I have to like hack a bunch of stuff together, and usually it'll be like a couple hours or sometimes days or sometimes weeks just to like even get it to compile, and then it finally starts to run, and then you basically, it crashes, you go over and over and over, and you finally get to step one. But what's different about XNA and FNA, which is my reimplementation of XNA, is that I can do ports pretty quickly. This was around the time where FNA was finally getting to the point where our compliance with XNA behavior was really, really good. So I was doing like, I was doing ports from start to finish, including QA, in like 8 hours total. So I'm thinking like, okay, it's just another XNA game. Yeah, there's like a Steamworks wrapper that's kind of messed up, but I can fix that. I've done it a million times. And so I'm like, okay, we're going to get right to step one, and it's going to work. And it's, oh God, that's not what I wanted. And so, what is that? Yeah, so I'm looking at this and I'm thinking, well, I mean, all the blocks are there. So let's just open up API Trace, which is, for those who don't know, if, API Trace, if you ever want to learn how a game renders out a frame, API Trace is a really good tool for that. You just run API Trace against like an exe, and then it just logs all the calls, including all the data that goes through the calls. And you can kind of see what's going on in each individual frame. And so this is a sort of a snippet of what I was looking at when I was debugging murder miners to figure out what on earth that was. What I noticed is that on the left is basically just each frame, and it lists the number of graphics calls on the side, and I'm like, wait, hold on, 191. That's like, there are 2D games that like, for context, 2D games can sometimes be several thousand calls, and somehow they have a 3D game running in 191. So that's cool. I'm thinking, all right, that's nice. It just means I have less calls to deal with. And then I actually look at the calls themselves, which is on the right, and I'm thinking, this is actually really well packed. Because, I mean, basically what they're doing is they're setting up render state at the beginning, they're binding the textures, they're setting the vertex buffer, they draw, change buffer, draw, change buffer, draw. It's very well optimized. Even in the context of Xbox games where you had a really crappy runtime getting in the way of your game, this is actually really, really nice. So I was kind of impressed. I'm like, oh, this is, I don't see that very often, especially not for 3D games. So then I ended up just randomly picking any draw call, and on the bottom right, I've sort of blown up the color buffer, which is basically just what the frame looks like at this particular point in time. So on the bottom right, this is basically showing we're in the middle of drawing all the blocks, the broken blocks, but at least they're there. But that part actually isn't interesting. What's interesting is this bit here, which is GL texture 0, GL texture 3D, which is weird. 3D textures are not common. Now, most of the time, you see like texture arrays or like cube maps, not specifically 3D textures. So this went from kind of cool to starting to get a little bit weird, and maybe I'm thinking, you know, I have 3D textures implemented in FNA, but I'm thinking, oh crap, I must have just done something wrong because nobody uses this. But as it turns out, I had it right. Where did my mouse go? Okay, so I actually had it correctly working, and on the right, or not the right, the left. So if you look at this thing right here, and we go back to this guy here, you'll notice that little graph texture is all over the place. And you compare it to that. So look at the grass, white blocks, grass blocks, and then we look at this. So we have the grass texture right here, and then we have what we actually want right here. So I'm thinking, okay, it's like a weird off by one, which is not terribly uncommon, but it seemed a little strange. So how it works, this is all 2D, of course, because it's when you're looking at a trace, you can't like visualize a 3D texture. You kind of just have to go, okay, it's 32 by 32, and then they just allocate like each Z value is a different 32 by 32 image, which is weird because I happen to know that the game doesn't, the texture isn't specially packed in any way. Like this is literally the sprite sheet. You can, if you download Murder Miners and you go to a texture folder, it's a customizable texture. So it's just a PNG file that you can actually edit, And they give you documentation, like you can kind of make texture models. It's sort of like Minecraft. They even say in the documentation, it's basically like a Minecraft texture pack. So just edit the PNG, and they actually have hot loading support for it. So they have a customizable sprite sheet that is a hot loaded 3D texture. So this is really starting to get weird. I'm thinking like it's not especially with XBLIG games, like you're not thinking about like modding support at all. So we're now at a place where it's super optimal. It's got a very strange texture format that is done in a way that users can actually interact with it. So I'm actually I'm starting to get kind of impressed. Like this is now at the point where I was thinking it was just like going to be like a gimme project, and it turns out this is getting really weird. But it's off by one, and it's complicated on like I can talk about like GL crap all day, but it's really just an image that you're trying to sample from. So what's going on? So up next, we have to deal with the shaders. So I'm thinking maybe the texture coordinate's off in some way, so I'm going, okay, so what's the shader doing? So the pixel shader turned out to be really boring. Because the shader has basically, you can get 2 inputs for a shader, which is like global parameters, and that was all boring stuff like a bunch of like lighting numbers and stuff like that. Had nothing to do with texture coordinates. And the input for the pixel shader was just a texture coordinate. So it was like XYZ value was already calculated. So I'm thinking, okay, the pixel shader is boring, so now we have to go to the vertex shader. And before I can even look at the vertex shader, I look at the input. Float for data position. What? So I'm thinking, okay, so I need to figure out what this vertex even is, because between the vertex shader input and the pixel shader, there's no way they're getting texture coordinates. There's no way. It doesn't make any sense to me. And so I find out the vertex type, and I get this. You will notice, if you're a programmer, that the entire struct is comments, and there's exactly 1 value. And I should point out at this point, you will notice the vertex shader input is float4. Turns out in reality, HLSL just works in float types. It's actually a byte4. So what all of this is effectively documenting is they basically have position, a normal, a color, a texture index, a corner index, and an offset. 28 bytes of data. They somehow packed this thing into 4 bytes. Again, this is like, for real, this is XBLIG we're talking about. This is like a community of like mostly like amateur programmers who don't really expect to be thinking about things in this way. And like, this is fucking awesome. Like, I don't get this, like, even like real like big studio games, like I see vertex buffers that are so damn large you can like fit the entire soundtrack in there in like FLAC format. So it's like, seeing this is really cool. No.
It's a racing game that just came out on the Nintendo Switch, and Shin is very notorious for making games that look like it should be like 10 games. They're very good at compressing into very small files.
Oh, good.
Bastion is a 10 gig size looking game that's only 500 megabytes.
Oh, that's wonderful.
Yeah.
Yeah. Unfortunately, with XNA, you don't really, because the content pipeline, the way they compress data is, I mean, it's okay, but usually the reason I don't have a content pipeline in FNA is because like to replicate the compression, and it's just like, it makes me squirm because I think about that and I'm like, oh, you could totally do it, you just have to try, and then all the XNA developers look at me like, no. So finally we get here. So like I'm thinking, because you see texture index, so I'm thinking, oh, so like it's off by 1, so I'm just thinking, screw it, let's just increment it by 1. And so we get here. I'm like, all right, we're on our way to getting this ready. But the problem is that's actually not right. Can anybody see what's wrong with it? It's real subtle. I'll give you a hint. I'll give you a different angle. It looks like this. Oh, and if you want to see it from the other side, I'm just kidding. There's actually no other side. And by the way, both those screenshots, I was standing on nothing the whole time. So this is just like, this was supposed to take me like 2 days. I'm sitting here like staring at API traces and looking at all these blocks going, what the hell is going on? And I finally managed to figure it out. I mean, I don't feel like I need to document me freaking out for like, several days trying to go line by line and looking through like ASM and trying to figure out what the hell's going on. So here's what happened. And I must emphasize one more time, this is just an XBLIG game we're talking about. It's just an XBLIG game. So how it works is the way they have it set up as a 3D texture, which has 256 values. So it's like you have 256 sprites. It's 32 by 32 for each, and then the way you access each individual sprite is by having different z values for each. Pretty simple. And so the actual size, when you pass it in with that packed byte 4, is that it's just a 1 byte vertex value. So like it's just 0 to 255. But the weird thing is that you can't really do that in the world of in like HLSL, because the way texture coordinates work is it's 0 to 1. It'd be I mean that's just how it is. I mean, and it's not. Normally, that's not really a big deal because the odds of it actually like being off are kind of very, very rare. You would think that it would be kind of imprecise, but it hasn't. That's not really the case, except in this one case, but not for the reason you would think. So how it works in the shader is that it takes the byte value and then it just divides it by 255. So it's like if it's like the very last sprite in the sheet, it's just 255 and it just happens to do 1.0. Makes total sense. What's interesting is that the way shaders compile is that they don't like, there are two things that shaders don't like doing. They don't like branching and they don't like dividing. I don't know why the dividing one, but the way it gets emitted in the assembly is it actually takes tile over 255 and it separates the division. So it's tile times 1 over 255 and then it stores the 1 over 255 as a constant in the shader. So you look at it like if you were to like printf that value, or not printf, specifically not printf, but like this is what 1 over 255 looks like, right? And so you would think printf, like I literally just said it and I wrote these slides, I already made the mistake. Anybody know what's wrong with this? Because it is broken. It's really subtle. Any ideas? So here's the thing. Printf, it actually, for whatever reason, does not go as far as it can in terms of precision. It happens to be that printf for floats only goes up to 6 places. So what was happening is that it was dropping, and you'll notice where it stops taking in values is the 5. So what was happening, it wasn't rounding, it was truncating. So it was literally 1/10,000,000th off to the point, and that 1/10,000,000th was enough to make it so that every single tile, except for the 0th tile, was 1 tile too low. So, yeah, I mean, so it was just, yeah, it was a little odd. And if you really want to, I mean, it sounds like I'm like, just talking about it's losing my mind, but the reason that is because all that work, going into all that data, understanding all of it and going through all the steps and figuring out this whole thing, this was the fix. Yay. So yeah, it's fixed now, but I mean, that took a while. And the thing is, that was just one game. There are thousands of these. And we have to figure out how to be accurate for all of them. And so this is where we have to talk a little bit about our visual again. So we have our game running on XNA, running for Windows. But of course, with XNA being discontinued, we have to find a way to preserve that, especially since we didn't get source code. And so my solution to that was a project called FNA. How it works is that I basically just have spent the last actually on Monday, I'll have been working on this for exactly 5 years. And basically what I've been doing is I've just been taking as many games as I possibly can and I just make basically as much of a replica of XNA as I possibly can. So all the behaviors, all the APIs, all the features, I go in and I implement every single one of them. As of now, it's actually super, super thorough. There are very, very extreme exceptions that I just like literally cannot understand. So like there are things like XWMA decoder support. Oh, and one thing about XNA is that if you're wondering why some XNA games will not boot on a fresh install of Windows, it's because XNA depends on Windows Media Player to run. That's a real thing. No, Exact is actually different. So it has both Exact and Windows Media Player. And so if you use Song or Video Player, it actually is running Windows Media Player in the background and just like loading it into as data that you can use. It's awful. So there are some, so like I don't have support for like Windows Media video files. Like so far, usually how it usually goes is when I talk to an XNA developer, I'm like, yeah, you can't use WMA anymore. You have to use OGG. And before I can even apologize, they're like, oh, thank God, I love you so much. But like, so like sometimes the exceptions work out, and then there are cases where like I'll extend it to fix, like for example, a lot of the things that I extend in FNA are things that fix the really shitty PC API. So like the fact that the keyboard doesn't have support for like scan code detection or like keyboard layouts, so I'll have like get key from scan code, so you can have a ZERTY detection and various things like that. We have get GUI.txt, so if you want to detect PS4 controllers and do PS4 prompts for the right controller, we have support for that. We actually support PS4 controllers natively, so we actually support every single controller that's ever been through Steam in general. Valve actually gave us a controller API to where whenever you configure controllers in Steam, they basically just they emit a string as an environment variable. So any controller that's ever been through Steam works with FNA by default, automatically, no configuration. And so, and in addition to that, we also have things like single assembly portability, where because it's C#, it's not like you're compiling native executables, it's managed code. So it's like when you take an FNA game, you don't have to do a Windows build, a Mac build, a Linux build. That's stupid. It's managed. We have runtimes that deal with this for us. So when you do an FNA build with a single assembly portability that we designed it for, you actually get, with a single build, from any compiler you want, a Windows build, Mac build, Linux build, OpenGL, OpenAL 32, 64-bit, Direct3D 11 Angle, OpenGL 4.5, experimental that I'm still working on, OpenGL ES, it's also going to be WebGL 2 for when we do the web support, OpenGL, all with one binary. And so the idea is that you can take these closed products that you have that are running on XNA, build it on FNA, and basically do whatever you want with it. And so you go from having this, so like the most simple way I can kind of show it is like you basically just take your XNA game that's running Windows, put it through FNA. Should be exactly the same. Might have a couple perks like the controller support and better full screen support and better media support. But like the idea is that it should basically be the same. And of course, what we like to do when we have control over our software is we like to port it. So for me, it's like, I'm a Linux gamer and a Linux developer, so I'm like, okay, let's take the FNA game, put it on Linux. And you have the power to do that. So like you can port it wherever you want if you have the power to do so. So like if you want to put it on Xbox One, if you were previously an Xbox 360 developer and you want to make an Xbox One version, you totally have the power to do that if you want. And so what's great about this is that in addition to having control over where your software goes, you actually have control over the software inside as well. So like I mentioned, so you mentioned Exact and Windows Media Player, like all XNA like has all these dependencies underneath that you really can't control, and a lot of them are just straight up dead now. Whereas with FNA, we actually have made a specific point of taking that same design where XNA was sort of something on top of various libraries. In FNA, we do exactly the same thing. So for like platform management, like window controller support, we use SDL. For audio, we're using OpenAL Soft right now, but I'm currently rewriting that to also use SDL. Mojo Shader, we use for effects. So if you use effect shaders or HLSL or just like precompiled shaders in general, Mojo Shader is a good way to get that, to use OpenGL shaders, metal shaders, working on SpearV for Vulkan, and some other things I can't quite talk about right now. What's great about this is that, speaking of, like, if you take Mojo Shader, for example, like, if you like have XNA games, but then you move on because you want to like write your own stuff, but you really like using effect files for shaders, you don't have to lose that feature because you have Mojo Shader now. And what you can do is you can take Mojo Shader and bring it to other projects and have the exact same code running the exact same thing, running the exact same way, and not have to deal with FNA as a dependency if you don't want it. And like, if you don't think that's a very common case, what's a really funny story that I have about this is as soon as I integrated Mojo Shader and FNA for our effects support, the very next game I worked on, which was not XNA, needed effects support. So like almost immediately after I finished support, I was able to reuse it instantly. Gratuitous Space Battles 2 is that project. And then at the same time, a friend of mine, Aaron Melcher, was working on Outland, which also needed effects. So I was able to work with him on that. And by having all this work on gratuitous space battles and Outland and Shank all working on Motor together, that was able to go right back into FNA, and we were able to get that benefit in the XNA reimplementation as well. And that's like, this is how a software ecosystem is supposed to work. How it works is you're supposed to have common code, and you're supposed to share it with people. That may seem like strange because you don't really necessarily know, if you're not experienced, what is reusable. But once you have enough experience with multiple projects and other people's projects where you're doing common things, you will find cases that you can turn something that you thought was just like some throwaway piece of code and make it something really, really valuable as a reusable library. And this is one really, really good example. And so, like, we've been really successful with this. Like, we've been able to, like, we have all these great features, we have all the extensions, we have a really healthy ecosystem where all kinds of games, like, I mean, we share code with Dota 2. Like, being able to have, like, the manpower behind Dota 2 and have it work for XNA implementation is kind of awesome. And so but that's all sort of all the things around XNA, but we are burdened with the process of actually re-implementing XNA. So that's sort of what I set out to make FNA's role, was just the XNA stuff, and then we try to make it so that everything else kind of can be in service of one another without us doing non-invented here, which is what a lot of projects will do. The problem is that XNA re-implementation, as it turns out, is kind of hard. Not just on a technical level where it's just like the API is huge and, you know, lots of things are undocumented, like Sean Hargreaves' MSDN blog was basically the only way you understood how XNA worked. And the problem is that we have to write it in a clean room too, because in addition to all the technical things, we have the legal things as well. So we can't really touch XNA all that much because, of course, like, you know, you can't disassemble it or we can't decompile it. Not that you really can, because it turns out XNA is mostly written in C++ anyway, though they don't tell you that. So we have to find really clever ways to deal with how we can make FNA actually accurate to how XNA worked. The good news is that, of course, we have lots of games we can work with. So we can sort of take apart XNA games. Of course, we have to deal with the legal issues of that, like we can't just decompile whatever we want. And so we have to deal with the fact that we have to figure out how we can actually access XNA games. So sometimes it's a matter of just figuring out how we can get in touch with the developer, which oftentimes, like with XBLIG games in particular, it's really common for developers to just not exist at all. Like all you have is a company name with no website, the website's down, there's no contact information, the email address is full. There's a million reasons that developers just vanish from the universe and just in general. So the thing is, a lot of people will just say like, oh, okay, we have a lot of sample code you can work with. Like XNA has a lot of sample code you can work with, like the Bloom sample and like all these samples that people are really familiar with. But I'm going to be honest. When you're trying to advertise a reimplementation and how like well it works, you kind of can't use the samples. To put it really, really simply, like just samples aren't sexy. Like if you're trying to really advertise something, you need it to be really sexy. So we can't use this. We need stuff like this. And so when you're trying, like, you would think that's kind of a hard problem, but I'm in a very, very convenient position because as it turns out, of course, I'm professionally a porter. So a really easy way to get people to pay attention is to just say, okay, I can take your XNA game and port it to Linux, a lot of FNA's initial development was just in cooperation with Humble Bundle when they used to do Windows, Mac, and Linux required. So we could basically, Humble used to be this massive force where we could just go to any XNA developer and be like, hey, you want to be in a bundle? And they'd just be like, okay, just tell me what to do. And that's been successful, but the reality of it, even with Humble at the time, was basically how it would work is I would email an XNA developer. Sometimes I'd get an email back, most of the times I wouldn't, and then oftentimes I would just get a flat out no, like they wouldn't even consider it. And then sometimes they would say yes, and so they would give me the source code, I would put it together, I'd run it and see what's necessary, like I'd basically spend 1 or 2 days assessing it and see what it needs. And then it's typical like contract work, like you take a look at it and you give a budget and a timeline, and hopefully they will say yes. Oftentimes it's no, because of course, like with XBLIG games, there's not really much of a budget in the first place. You've probably, if you're in the world of like contract work or like game development or like work for hires and stuff like that, like I mean, you've heard this story a million times. And it's worked, sort of. I mean, we now have like 60 games working on FNA that are commercially available, and we have lots of like samples and test cases working really well. But percentage-wise, that's not great, because we have like 2,000 games, and I'm like, yay, we have 60. Oh, okay. And so, I mean, that's sort of what I've been dealing with. That's sort of what I'm going to be trying to deal with this year. Where FNA is at right now is, I mean, it's now at a point where developers can now use FNA. I don't have to be constantly hovering over them. It's not this in-development experimental thing. So like Axiom Verge and Terraria use it, and there are a bunch of different games that use it independently. They even use it on Windows to replace XNA, so they don't have to require like the XNA redist. We don't even, FNA doesn't even require like the Visual C++ redist, so like you can whittle it down to like .NET and like DirectX redist. So, you know, if you're a Steam user that really hates redists, like FNA is a really good story for you. And of course we have a lot of new games using FNA, so like we have Chasm and Tooth and Tail. Blue Line games, I can actually happily say that Steam's chess game, like every platform needs a chess game. The chess game on Steam uses FNA, so I have that to my name. And of course, and Midboss, we actually have the developer of Midboss with us. Hello. But yeah, go get Midboss, ask her about Midboss. She's here, talk to her about it. But I mean, that is the cold hard truth of it is, you know, it's still a really, really tiny amount of the library. And so we've sort of been trying to figure out how to deal with the problem of how do we make our data set larger? Because when you have a proprietary game, you're stuck. Like there's nothing you can do. So I thought. So there's a developer in Germany called Mike Macho. He's a developer of Monomod. And basically he was just like, yeah, it's a binary, but that's not necessarily a stopper. And so he came up with this tool called XNA to FNA. What it does is it takes XNA binaries like a game.exe, and it has dependencies on Microsoft.xna.framework.dll, and it basically using reflection without decompiling it. So it's like right on the edge of like being legal. So he basically takes all of it, and any data basically goes to the reference list, and any XNA reference, he just makes it point to FNA.dll instead, and just emits a new binary that looks like an FNA binary. And I'm like, but like conceptually that might seem realistic, but I mean I've dealt with like C#.NET is like really, really fragile, and I'm thinking, okay, this is just on the edge of what seems realistic, because it's like, okay, you can't just change references. It's like changing the LDD like paths on like a Linux binary and expecting it to work. Like that's not possible. Turns out I was wrong. So this is One Finger Death Punch working natively on Linux using the Windows binaries. Everything works, including Steamworks support. So when I was first running this, I actually was unlocking achievements on Steam on Linux with Steam for Linux. Like, and it worked. And tons of games work like this. We have like the entire Zwoid games catalog, so like Cthulhu Saves the World, Penny Arcade 3 and 4. We have Mount Your Friends working. We have One for Death Punch working, and like they work. Like this crazy idea, and I think he was like 16 or 17 when he wrote it, and like most people, this is one of the reasons why I really like working with like really young developers who like, hey, I have a GitHub repository. I'm thinking, oh, I mean. Because you normally, like with students, like they're so desperate. They're like, I have no idea what I'm doing. And then there's guys like these who are like, hey, I made this like Windows game work on Linux natively. I'm like, I love open source development so much. But I mean, of course, like this is sort of on the edge of legality and like sort of ethics and now it doesn't work 100% of the time. There's always things like sometimes they reference Win32 API, or they have system.windows.forms dependencies. So like sometimes, well, it's great for prototyping. So I can take a prototype like this and I can give it to a developer and say, hey, we basically have it working natively. Can I just like make it an official version? It'll take me like a weekend or something. Sometimes it works amazingly. Sometimes it does not. Like even when I have it working, even if it's like works. And it has the budget for it. Like we had Stardew Valley actually working on Linux pretty much right when it came out. Unfortunately, like in that, I mean, to be fair to the publisher of Stardew Valley, they actually signed something like right when it released. So when we were giving them this prototype, we were really excited, like, oh man, they're gonna let us do it, and they went no. But like, I mean, it took them, the porting team for like Linux and macOS, for example, like months and months and months to do. Meanwhile, Mike and I were playing Stardew Valley on Linux like pretty much the month that it came out. So it's a case where I'm hoping the tide changes a little bit, where we can take these prototypes and people will say yes more often. But we do have to accept that technically this gives us a good set of data, but it is sort of a business dead end because, I mean, doing all the setup to get all this is kind of a big pain in the ass. And if you're wondering about the XBLIG side of things, we have this working with Xbox 360 games now. Literally like 2 months ago, Mike figured out a way to take XEX binaries dumped for an Xbox 360, and now we have Xbox 360 only XBLIG games running on Linux natively. So like, we're getting places. It's doing really, really well. It's a lot more intensive because we have to deal with like Xbox 360 is big endian, so we have to kind of do a whole bunch of like data conversion like at like build time or runtime and stuff like that. But we're now getting to a point where we're starting to see a possible route where we can take the XBLIG data, provided somebody has it. There are a couple of people that apparently dumped the entire Xbox Live Indie Games catalog. Are there any of those people in the room? Because, but this is a good start. But this is like the modder part of my brain talking, where we can sort of hack it to work. But of course, I am a commercial developer, and so I do need to point out to people who think, oh, I can just let them do this hack port. We do need to talk a little bit about our implementation because, as you know, every game has like trial mode, and you unlock the trial, and that's all linked to Xbox Live, and we can't implement that. So basically, in order for us to work with this data set, we basically have to crack the entire XBLIG catalog. So, I mean, if you're a developer, indie developers, like, ask anybody who's in the indie scene, like, every sale counts. So if you're in that realm where you're desperately trying to get as many sales as possible, you really, really want to consider making a real commercial port of your game, because otherwise, it's the service problem of, if the best way to play your game is by basically taking stuff like this and cracking your game, I'm a commercial developer myself, so I totally understand why you would want people to actually buy your game. But like, if there's no other route, it's hard for me to say that like it's out of my control. So it's something for you to consider. So maybe don't just say let someone else do it, unless you're letting someone else do it by way of hiring a certain person to do port. But but like, of course, I don't want to be like, it'd be a shame if your game was pirated if you didn't port it. Like, I do want to encourage people to actually take their library of XNA games and kind of rebuild a community that sort of got slowly destroyed over a period of years. We do have a lot of the XNA community. Not as much as I would like, but it's there. I can actually say quite happily that there's a developer that used to be on the XNA team that actually has contributed and actually ships games on Steam with FNA, despite being on the XNA team, which is really, that was sort of a proud moment for me. Nick Gravlin, I think Shipwreck on Steam, if you want to see that. Even getting back to the ecosystem part, because we exist in an open source ecosystem where we have lots of common code with others, we actually now have people even at the graphics driver level working with us. So I've gotten emails from the Mesa team saying, hey, we found this thing in one of the AMD guys emailed me saying, hey, Rogue Legacy tries to do a BGR 565 render target. What are you doing? And I'm like, I don't know, let me go figure it out. And a lot of the data that he gave us and sort of his understanding of how for example, render targets actually work, we were able to kind of come up with a really good solution that accurately reproduces the render target writes that you're allowed to do, but at the same time, it works exactly how XNA would work, where we fall back to surface format.color, for example, instead of BGR 565. And I'm trying not to get technical, so I'll stop myself there. And I'm sure some of you are wondering when I'm going to bring up the Monogame project, and this is sort of the one line that I will bring it up. We do work with the Monogame team a little bit. The thing is, they're XNA-like. Sometimes they're XNA4 they seem to flip-flop between XNA4 compatibility and XNA4 successor based on whenever it's convenient. So we don't overlap too much, but there is a lot of like exact, for example, like there's a lot of data that we can share. So when we figure out new magical numbers in the binary blobs, like we'll share a lot of that data. And so there's lots of angles that that the ecosystem allows us to have a good community without being this isolated little forum that that was pretty much like all you really have left of the XNA community at this point. And so I really encourage you if you're a developer making XNA games, if you're a developer working on things like SDL or Mojo Shader, or if you're interested in if you're like a speedrunner and you're playing like an FNA game and you want to hack on FNA to make it somehow more beneficial to speedrunners, or there's so many different routes that you can contribute. And if you're curious as to how you can contribute, I really would just ask. I'm here all weekend, so I'm here to chill. And so I did want to have one slide at the very end, just sort of talking about what we're going to be doing in the future. I can now say after 5 years, it only took 5 years, but it's I finally have it at the point where FNA's code, I'm pretty much happy with all of it. I'm currently rewriting the audio subsystem to be mostly native code and a more accurate reimplementation of the exact runtime as a separate thing, because right now it's sort of contradictory to our ecosystem motto, where it's the exact implementation is stuck in FNA as managed code. So we're going to split that off into its own library. So we're going to have a totally separate exact subsystem where you can take any game that uses exact and reuse our stuff. And so I already have Resident Evil 4 working with it, because it turns out that game uses exact. So we actually have Resident Evil 4's audio data running through FNA's audio code, which is cool. Yeah, I was hoping I would have it done before this, but unfortunately there's a bunch of stuff I still have to do, because we're basically writing an entire audio mixer and reverb effects and filter effects from scratch, all in plain C, which is what I like to write in, and it's easier for porting. But the good news about this is that in addition to having mostly native code and having it finally be really, really good, we're getting rid of the last non-permissive license in our framework. So now we can finally basically port this to where we want without having to worry all that much about the licensing thing. So basically the idea is that I'm not going to be doing a whole lot of new code. I'm going to be doing a lot of porting to new platforms, or at least I'm going to set a foundation to where people who want to port can do it easily without me having to be hovering over all the time. The one that I have working right already is Xbox One. It turns out I can make it work by just adding a couple lines to main and just redirecting it, because we have to deal with UWPs, init crap. But luckily we were able to avoid all this XAML garbage and make it so that you don't really have to touch your code all that much. It seems to work just fine. I tested a bunch of games and it's running perfectly okay. There are some memory management concerns I may have to look at. But once FACT is done, I assume I'm pretty much 100% the API should just work. We've had Android for a couple years. I did want to bring this up. If you're wanting to target Android, we actually have it working now. But Mike has actually been the guy who made XNA to FNA. Most of his work was actually in service of Android, so he actually was taking Xbox 360 games and running them on Android. I don't know. I don't know what his deal is, but I love him. But the reason we haven't really advertised it is because even with our very, very, very compliant, very safe, very, very carefully designed graphics renderer, no matter what we try to do, we just cannot get Android to act correctly just at all. I mean, a lot of people who work with Android know this, but if you're an Android user wondering why certain games don't come out, it's because the graphics drivers blow so hard. Because I'm hoping Vulkan fixes this, because that seems to be a much better direction, but we haven't written the Vulkan device yet. So I'm probably only going to really consider Android once Vulkan is available and ready to use. Web browsers, we actually have some cases of XNA games running in web browsers. Caitlin Gadd, who wrote JSIL, had a distant branch where she was able to make it work. to some extent. There were a lot of hacks in it, and it kind of hit a dead end after a while. But it turns out Xamarin and Microsoft are working on getting the mono runtime to work as WebAssembly. So the idea is that we can take the single assembly portability of the Windows Mac and Linux game, take those, which is because our stuff is already WebGL2 compliant and have all of our native code are with WebAssembly, put it through the mono runtime WebAssembly and have a single assembly portability. So have one binary running on Windows, Mac, Linux, OpenGL, Directory 11, OpenGL-ES, and WebGL, and the web browser, all with one binary. So that seems to be the most promising platform out of the ones that I'm not actually looking at. There are people working on this that I can't really talk about right now, but hopefully that's something that will materialize later this year. iOS and tvOS, again, all of the code works. All of our native libraries work, like they're known to work, and there's nothing in the FNA source that would prevent us from shipping iOS. The problem is that actually packaging iOS apps sucks, so we're trying to get the mono runtime to build, and we have to statically link all of our native libraries in there, and then we have to figure out how to make signing easy to use, and we're basically trying to figure out how to make it a good user experience without having you dig up like Xamarin.ios. Like I wouldn't do it myself. I'm not going to make anybody else do it, so that's why we're taking our time with making iOS and tvOS work. But then, the one that I'm actually going to be working on, aside from all these, because these are all sort of secondary right now, the one that I'm actually going to be working on, I actually just this morning signed a deal. I'm going to be working on Nintendo Switch support. So basically, right, because I've had the dev kit for like 6 months, and I haven't been able to do much with it, but I finally can like sit down, and I have a few routes that I'm planning to take. I'm going to try and make it to where all these platforms I just listed work in service of the existing code. We're not going to like add like 16,000 different binaries. We're not going to add a bunch of different code paths. We're going to try and keep it within the ecosystem and have it work well, and have it not be a disservice to the desktop platform, which is always going to be platform number one for me, because I am, after all, a Linux gamer. So to sort of wrap up, here's a bunch of links. If you're interested in this, why does it keep doing that Google link thing? Anyway, so I mean, fna-xna.github.io is pretty much the only URL you care about, because all the stuff below is linked to on the front page or the wiki. I do want to point out the template from Andrew Russell, the lead programmer on City Ransom Underground, actually made a template that lets you get started with making new FNA games. It actually uses the monogame content pipeline separately, so you can get started with making games. You don't have to like look up a bunch of samples. You can just take that, and then you can sort of look at the XNA documentation, and it should just work as its own thing. So I'm like 2 minutes over time. Nobody's kicked me out yet, but I'm going to run now. If you have any questions for me, I'll be over there or something like that. Feel free to ask me whatever. I'm here all weekend. So usually my rules for MAGFest are: you bring the drinks, I bring the stories. So thank you all very much.